Okay, a couple of things to note before we start this video. We're going to calculate K, and two important points. If K is greater than 100, then it favors the products. We have lots of products. If K is less than 1/100th, then it favors the reactants. If K is between 1/100th and 100, then K favors neither. And this usually shows up as 0.01 is less than K, which is less than 100. So smaller than 0.01, it favors the reactants. If K is greater than 100 or 100, if K is less than 100, then it's in between. Okay? So here's a reaction at equilibrium. The equilibrium pressures are 0.8 atmospheres for N2O4 and 0.32 atmospheres for NO2. So we write our equilibrium expression, KEQ, which is Kp in this case because we have pressures, is equal to the pressure of NO2 squared divided by the pressure of N2O4. So all we do is plug our values in. When I plug my values in, 0.32 atmospheres squared divided by 0.8 atmospheres, I get 0.128, and that is unitless. It's between 0.01 and 100. It's greater than 0.01, and it's less than 100, and so it favors neither the products or the reactants. Let's do another one. So here we have, and these a reaction N2 plus 3H2 yields NH3, and so we know KEQ in this case is going to be Kp, which is going to be equal to the pressure of NH3 squared divided by the pressure of N2 times the pressure of H2, or divided by the pressure of H2 on the bottom. Okay, and so we plug our values in. Kp equal 4.61 squared atmospheres squared divided by 0.1 divided by 0.07 squared. All those are units of atmospheres. And when I do that, I get 6.2 times 10 to the fifth on this. And so this one favors the products. The reaction goes a lot. So reaction favors the products. Okay, it's way bigger than 100. Let's do a heterogeneous example. PbF2 solid in equilibrium with lead plus 2 plus 2F minus, and we have concentration of 0.3 molar, 4 times 10 to the minus 7th, and I should have my aqueouses in here, so you know. And this is a solid, so it has no concentration, and so we write our equilibrium expression, and this is KEQ, which is going to be Kc, which is going to be the concentration of lead plus 2 times the concentration of fluoride minus squared, and that's going to be pretty easy. 4 times 10 to the minus 7th molar times 0.3 molar squared, and I get 3.6 times 10 to the minus 8th. And so this one favors the reactants. So if it's very small, it favors the reactants. If it's very large, it favors the products. One thing you should know, remember, the concentration of a solid is always 1. It's actually pure solid. For us, it will always be pure. For a pure liquid, even if you don't think, if you see that L sign, it equals 1. Okay, that's it.